In counting methods, one of the most elementary sorts of rules that we're going to take a look at for more than one event occurring is going to be this thing called a multiplication rule. Now, let's say there's a certain number of outcomes for event A, and let's call that M, and let's say N is the number of outcomes for a second event B. The total number of outcomes for the events at the same time A and B is M and N. All right? And the most prolific example I've ever heard with this is, let's say you have a closet and you have shirts and socks, or maybe shirts and pants. So let's say that for some reason in your closet you have 5 shirts, or let's say 4 shirts in your closet, and let's say that you have 3 pair of pants. Well, the total number of wardrobes that you could get, the total number of shirts and pants, would be 4 times 3, which is going to be 12. Right? So that's probably the easiest example that I can think of to be able to illustrate the multiplication rule and when we could use it. Okay, so a lot of times the multiplication rule is the most fundamental rule in cryptography. So if you're trying to create some sort of firewall or some sort of algorithmically generated code or decode, the multiplication rule might be able to be the most fundamental way of being able to figure out how many different codes there may be. So an example of that, let's say for some reason that you might have a garage door or some alarm code, and the alarm code is chosen from any of the 26 letters of the alphabet. How many 3-character codes, okay, so that's important, and also 26 letters of the alphabet, so many 3-character codes can be created if, first of all, repetition is allowed. All right, so let's say on the first letter there's 26 possible outcomes. If repetition is allowed, there's still 26 possible choices on the second. And then on the third letter, there's again 26 possible outcomes. So in reality, the answer is 26 to the third, or if we were to compute that, that's going to be 17576. What if repetition is not allowed? Well, on the first, there's 26 possible outcomes. On the second possibility, there's only 25 letters, because whatever letter we've picked, and we don't know what it is, but now that's crossed out of the list. On the third choice, there's only 24 letters. And the reason is because now we've canceled out 2 of the possible outcomes. Answer, 15,600. Third example. Repetition is not allowed, but there are no vowels. Now remember, in the alphabet there are 5 vowels, so now we're only dealing with 21 possible outcomes. Right? So, and the vowels are not Y or sometimes W or whatever it is. We only count the basic A, E, I, O, U. So if I give you these types of problems, just use the standard definition of vowels. So there's still repetition is allowed. So there's only 21 outcomes. And we're going to do that 3 times. So that's 21 to the third power. If I compute that, 9,261. And then finally, repetition is not allowed and no vowels are allowed. All right, so on the first draw or the first selection, there's 21 possible characters. Since repetition is not allowed, 20 on the second, and then finally on the third, there are only 19 possible outcomes. So that's going to be 21 times 20 times 19, and I get 7980. So a second example involving the multiplication rule might involve license plates. Okay, so and this is the older way that Maryland used to do license plates. I think they started running out of different possible license plates, so that's why they make the new. I think there's more characters now in license plates in Maryland. So first of all, a Maryland license plate consists of 3 letters and 3 numbers. Okay, so we know that 3 letters There are 26 letters in the alphabet, and this probably should say digits, but we know that there are 10 digits, okay? So there are 0 through 9 when we talk about the digits. How many different license plates in Maryland can be made if, first of all, repetition is allowed? So remember, it's 3 followed by 3. Since repetition is allowed, 26, 26, 26, and then by 3 numbers, so there are 10, 10, 10. So I'm going to put that in my calculator. I'm just going to do 26 to the third times 10 to the third, and I get, I think it's 17,576,000. So 17576,000. For item B, what if repetition is not allowed? Well, with the letters, we have 26, 25, 24, but then we have a new group. Okay, so we know that letters and numbers are independent. There's no overlap. So then it would be 10 times 9 times 8. So we're going to stick that in the calculator. And I end up with, this time, 11,232,000. What if the first letter is a vowel and the last number is a 0? Right? Now, one of the most common errors is I see this. Okay, so the first letter is a vowel, last number is a 0. Notice it doesn't say anything about repetition. So if it doesn't say anything, repetition is implicit. Right? So it doesn't say, if it doesn't say, then you can just assume that repetition is okay if it's not stated. So the first letter is a vowel, meaning that there are 5 possible vowels, and the last number is a 0. So then we have 26 choices and 26 choices again, okay, because it doesn't say anything about repetition not being allowed. Here's a very common error that students make. All right, so the first letter is a vowel, the last number is a 0. So we have a digit, which is 10. We have another digit, which is 10. And then sometimes what students will do is they'll put a 0 in there because the last number is a 0. But that doesn't make any sense, because if we were to do that, then the whole thing would be 0. And that doesn't make any sense to us. We remember that there's only one character of 0. So what we're going to do instead is we're going to multiply that by 1. All right, so I'm going to stick this in the calculator. And I end up with 338,000. All right, so be careful when we ask for a specific digit or a specific letter. Remember, there's only one letter or one number that satisfies that condition. Letter D, the first letter is a vowel, the third is a consonant, the first number is a 1. Okay, so first letter is a vowel, 5. Doesn't say anything about the second letter, so that's still 26. And then the third is a consonant. Now we know that if it's not a vowel, it's a consonant, so there's only 21. The first number is a 1, so there's 1, 1, and then it doesn't say anything about the other 2 numbers, so those are still both 10s. Right? So I'm going to put that in the calculator, and I get 273,000. So hopefully these two examples are helpful for being able to understand the multiplication rule.